our lessons so that you can do it when you're at home at school for tomorrow on your show day. Okay, now we're not going to talk to you anymore because that's weird. Okay. Thanks for the door. It gets so hot in here. Can you try it with it open? Yes. Okay. All right. So what we're going to be doing today is remembering how to factor. Okay. And I don't think that I'm going to show you anything you didn't learn last year, but I'm going to show you what you spent 2 weeks on in 45 minutes. Okay? And so you have to kind of remember everything that you learned last year about factoring, maybe a little bit new or something. Okay? So there are several kinds of factoring. And the first kind of factoring is called GCF factoring, which stands for
Greatest common factor.
Oh, never been quite so together in your responses. Okay, greatest common factor. And I always think of greatest common factor as backwards distributed property because that's what it really is. It's just distributed property. So you might see a problem that looks like this. And this has 2 terms, and so with greatest common factoring, you are looking for a common factor in each term. So what can divide into 8 that can also divide into 4, everybody? 4. And you put that on the outside and a set of parentheses, and then you put on the inside what you would get if you divided each term by that greatest common factor. So 8 divided by 4 is 2. So I get 2x, and 4 divided by 4 is 1. So basically, you learn how to take this and do distributed property, this with this part, get that answer, and so now we're taking this part and undoing it back to the distributed property rule. Familiar with everybody? Okay. So we've got 2 or 3 examples of this. A lot of times in Algebra 1, you focus just on pretty straightforward things with just x in it or just y in it. So you should be able to do it for things that have more than one variable. You want to look at each component, each factor type. So the coefficient, what's the common factor for 8 and 6? 2. This has x cubed, and this has x. So what do they have in common? It's going to be the one with the smallest exponent, so 1, x to the first, and then y and y cubed, and so that will be 1. If you had 2 terms before, you will have 2 terms inside the parentheses when you finish. And you can either think about this as what do I multiply by? You can think of it that way. 2 times what is 8, or you can think of it as 8 divided by 2 is 4. Okay, x cubed divided by x is x squared, and y divided by y is 1, and so there won't be any y in each. Everybody got this? Okay, the next one then would be 3 and y squared. This works no matter how many terms you have. So here's one that's got 3 terms. What do you call one of these things with 3 terms? 3 terms. And if you're going to do GCF, you're going to have to do something that's in common to all 3 of the terms, not just with 2 of them. It has to be in common with all 3 of them. So what goes into 3 and 9 and 6 is 3. They all have x's, so you pick the one with the smallest exponent. That's what they all have in common, so that's going to be x. And inside the parentheses, you're going to have 3 terms left over. Okay? And then again, either asking yourself what do I multiply by, or working it as a division process. 3x cubed divided by 3x is x squared. 9. X squared divided by 3x is 3x, and 6x divided by 3x is 2. Okay? So what can I factor out of this one? 4 and x squared. You want to pick the one that has the smallest exponent. That has an exponent of 3. That has 2. So you take the one that's the smallest, x squared. And I put this one on here just because one of the most common things for people to do is when the whole term is factored out, they sometimes forget that there is still something left over. We are dividing to get these answers. This is 4x cubed divided by 4x squared, which is x. And the next one is 4x squared divided by 4x squared. That's not nothing, it is 1. And a lot of times people forget what that 1 is. Okay, so greatest common factors. Backwards distributed property. backwards distributed property. It's really weird to do this when there's no one in the room. I did this for my AP calculus class tomorrow, and I talked for 35 minutes and there's nobody in here. It was very weird. And then I listened to it and I sound like my mother. I'm like, that's my mother, she's teaching calculus. Okay, all right, so the next kind of factoring is called difference of two squares. Difference of two squares. If you can grab a hold of the name of the thing, sometimes that'll jumpstart you when you get a little bit confused and are unsure what you're doing. Okay, and I think you're going to remember these. Difference of two squares problems look just like what their name is. It's a difference, minus. It's got only two terms. There won't be three terms. And both of the terms are perfect squares. Okay, so that's what they look like. If they don't look like that, they're not difference of two squares problems. And these can be factored into two binomials, like this. We usually set two sets of parentheses. One of the parentheses needs a plus, and the other one needs a minus. It doesn't matter which one you put first. And then these two terms right here have to be the same. And when you multiply them together, they've got to give you this first term right here. So what can I put there? What times what is x squared? X times x. Okay. And then these two terms here and here have to also be the same. And when you multiply them together, they have to give you 9. So what times itself is 9? 3. And so this answer, just to write without all that mess around it, is x plus 3, x minus 3. Y'all remember learning that last year? Yes? Okay. So the big thing about difference of two squares, it's like super easy. It's just a matter of recognizing it in some of its different forms, making sure that you don't miss it. There's nothing magic about the variable coming first. That doesn't have anything to do with it. You cannot switch this around. Somebody always does this. They say, oh, I don't want the m squared at the back. I'm going to turn it around to this. And I need you to all look at that and recognize that those two things are not the same. Okay? What's this number? 4. What is it when you do this one? It's a negative 4. They're not the same thing. So you cannot switch this around when there's a minus there. Okay? Just leave it like it is. This is a difference. There's two terms, and everything in that whole thing is a perfect square. Okay? 1 plus and 1 minus. These two need to give you 4. So what goes right here? And these two need to give you 25m squared, so that's going to be 5m. The thing about difference of two squares is it has to have the same terms in each of the binomials, only one with a plus and one with a minus. Yes?
Could you do negative 25 plus 4?
Except that then it doesn't fit the pattern, and it makes it more difficult to actually do the difference of two squares factoring. It's easier to leave it just like this. Because difference of two squares factoring has to have a minus in the middle. Okay. Really virtual. Okay? All right. You should know all of the perfect squares up through 144. Yes? 1, 4, 9, 16, 25. Up to 144, so that when I give you one like this, it won't take you any time at all. Say, oh, those are perfect squares, 36 and 49. Yes, perfect squares. It's a difference. One's got an X in it, and the other's got a Y in it. So what am I going to need to get 36x squared? 6x. And put the same thing in. 1 plus and 1 minus, and what will I need for 49y squared? 7. Okay. Okay, that's one of this example. Okay, is it a difference? Yes. Does it have two terms? Yes, it is. Are all of the factors in here perfect squares? Yes. Okay, so it fits the pattern. Two sets of parentheses, a plus and a minus, and then you just pop everything in. And every once in a while, somebody will do something like this. And not that this isn't the answer to something, but it's not the answer to this question. Okay, these two things do give you 16a squared, but in order for difference of two squares to work out, this and this have to be the same term. You have to put the same thing in both of those spots. Okay, so this isn't gonna work for difference of two squares. Instead, what am I gonna put instead of 8 and 2? 4 and 4. Yeah. Okay, difference of two squares. Okay? All right, now this next one is also one that is not particularly hard.
What's it?
It is not one that every Algebra 1 teacher does. You may have seen it or you may not have. Okay, but it is one you just need to memorize. So those of you who like to have highlighters to remind you about things, this is a good place to do it. Okay, the sum or difference of two cubes. It's got a particular sum or difference. Or
I thought that was the one.
yeah, up to, I get that a lot, sum or difference of two cubes. So the first thing is, like you know all your perfect squares up to 144, right? You need to have in your stash of, I just know these things, a few perfect cubes, okay? So 1 cube is 1, so you need to know that 1 is called a perfect cube. Okay, 2 cubed is 8. 8 is a perfect cube. 2 times 2 times 2. Okay, the next one I would expect you to know is 3 cubed, which is 27. And we're gonna go up one more, actually 2 more than that. 4 cubed, don't talk, think. 4 times 4 is 16. 16 times 4 is 64. Okay, and we're just gonna go one more, just because this one tends to show up with some regularity.
125.
It's not a very hard. 5 times 5 is 25, times another 5 is 125. So I would expect you to know these 5 perfect cubes and recognize when you see them that they are perfect cubes, okay? And if you haven't had to do that before, well, you have to do it next, okay? So I'm going to show you the factoring pattern, and I'm going to do it with an A and a B, and then I'm going to do it with some numbers in there, okay? So here's the factoring pattern. It's like the rule. The difference of cubes doesn't factor into two binomials. It factors into a binomial here, A minus B, and then it factors into a trinomial. Let's write it down and then I'll talk about it. Okay, this is the factoring pattern. And the things that I want you to see up in here that have to be memorized are the following. Okay, first of all, the signs. This is a minus, and both of these are pluses. If you get the signs wrong, then it isn't right. Okay, the first is a minus, and then both of those are pluses. Now I'm going to work through this with a couple of numbers, or with a number and a letter in it, so you can sort of see how this pattern works. Here's what I'm going to do. X cubed minus 8. Okay? X cubed minus 8. And the first thing is you recognize that A is a perfect cube. Yes? Okay. So you either write this down or you think it. You don't have to always write that down. You could just think this step, but you should have it in your notes. Because the number that's important is not the 8. The number that's important is the 2. That's the number that we need, not the 8, but the 2. Okay? And now we're going to follow the factoring pattern up here. So a set of parentheses. And what goes in the parentheses were those two bases up here. So what are the two bases here? I can put it so right next to my it's a little bit higher. Okay. Okay. Then I have another set of parentheses. And then look right here. You've taken this one and squared it. Okay? This first one and squared it. So what's going to go right here? X squared. Okay? Plus. Okay. In the middle, we have one of each of them. We have A and we have B. So we have this and we have this. So what two things do I need here? 2 and an X. Plus, and then here, this one is that one squared. So what's 2 squared? 4. That's a little note. 2 squared. That's your factoring pattern. Okay? Did anybody do this last year? Many Algebra 1 teachers don't do it. Okay, so It's not hard, but it's new. We have to memorize it. So let's try another one, see if we can follow that pattern. Make sure you can still see the factory pattern since mine has scrolled off into the universe. Okay. So the first thing that you're going to recognize is the difference of 2, and everything in there is a perfect cube. 27 x cubed and 1, all perfect cubes. The 27 is not the number that you need. You need to put it down into its cube form. So what cube gives you 27? 3 cubes. So you have to think of that as a 3 cubes instead of as a 27. Okay? Alright, so the factoring pattern is a binomial with a minus in it. And right here, you put whatever it was that was being cubed. So you're going to need the 3 and the x. And then right here, you put this one over here. Well, I should have written 1 cube here. That's what you're thinking. Yes? So this will be 3x minus 1. Does everybody see where I got the 3x and the 1? Look at your notes. Have you got written in your notes where I got the 3x and the 1? So that when we have a snow day, and you don't look at this book for 3 more days, you go back and you look at your notes if there's enough in there to help you. Yes? Okay. Next, we need a trinomial, and our trinomial has 2 pluses in it. Okay? The first term in the trinomial, this one, comes from here. We take this number right here, whatever was there, and we square it. You square the 3 and you square the x, which will give you 9x squared. Okay? The term in the middle says to take this term and multiply it times that term. 3x times 1 is 3x. And the one on the end says to take the last term and square it, which is 1. Okay, easy enough? You just have to memorize it. That's the hard part. Okay, now at the beginning I told you that we were going to do sum or difference of cubes, and we just did difference of cubes. So the next thing we're going to do is sum of cubes, which looks just like difference of cubes, except it has a plus. And the bad news is, it's another thing to memorize. The good news is it's very similar to the other one. So they're not that, well, they can play both ways. Okay, I have a few tricks. So just like the other one, we're going to start with the A and the B here, but instead of A minus B, we're going to start with A plus B. So if this is a minus, starts with a minus. If this is a plus, starts with a plus. The terms in your trinomial are going to be the exact same terms as the other ones. The only difference is, instead of there being 2 pluses, you're going to have a minus and then a plus. That's the only difference. So really what happens is just, if they look exactly alike, but just the signs are different. Okay, otherwise these 3 things are all the same. This is still going to be a squared, this is going to be a times b, and this is going to be b squared. Okay, so if you compare them side by side, you can see that the only difference is what these are. This is plus, minus, and plus. Okay, let's try one. Lots of tissues and hand sanitizer. Okay, so this is a, ladies, this is a sum of 2, and both terms are perfect cubes. Remember that the 64 is not the number you need. You think that 64 is what base cube? 4. The 4 is the number that you need in order to write your answer. Okay? So a binomial, m plus 4. A trinomial with a minus and a plus in it.
So what do you multiply? How do you get from like binomial to trinomial?
Okay, the same way, this is just a memorized factoring pattern, okay? So this right here is going to be whatever you put right here, squared. So whatever you put down right here, you put it there and you square it. The one on the far end is whatever you put here, squared. So what's 4 squared? 16. And then the term in the middle is these 2 multiplied times each other, 4 times m. Okay? Now, if we multiplied that all out, and I'm pretty sure that was on a quiz or a test not too terribly long ago, so we multiplied all this out. If we multiplied all this out, we would get that answer right there. Okay? All right. This next one should have a slightly larger numbers in it. Yeah, I think we can handle it. Okay? All right. It's a sum. It's two terms, and every single factor up there is a perfect cube. Okay? So again, you've got to stop and think, what do I need instead of that 27? 3 cubed, right. Okay, and what do I need instead of that 125? 5 cubed. If you don't want to write this step down, that's okay. I think I would put it in your notes, but that's a step you can do in your head. You need to memorize the signs that you're gonna have to use. All right, so what goes right here in this first spot? This, yes, the 3 and the x. Okay, and what goes in the second spot? 5y. Does anybody have a question about where those came from? Okay, so what goes in this first spot here? This right here, this square. 9x squared. Square all of it. Okay, and what goes in this last spot over here? This square, 25y squared. Everybody with me? And then the middle spot is this multiplied times that. 3 times 5 is 15 xy. Okay? All right. That is called sum and difference of cubes, and it is a factoring pattern that you need to memorize. Now, I'm just going to, as a little aside, backtrack for just a second. Look at this one, as a reminder. Is this the sum of the difference of two cubes? No, this is the difference of two squares. So it's a different factoring pattern, and you factor that one as x plus 4 and x minus 4. Look at this one. Is that a sum of two cubes? No. Is it a difference of two squares? No, this is not a difference of two squares. Okay, and it's not because it's got a big old plus in the middle of it. So you can't factor it the same way. It doesn't work. All right? Okay. Does anybody remember the other kind of factoring? It's actually the one that you probably spent the most time on. We did guess and check. We did GCF. We did difference of two squares. Who remembers the name of the other kind? Say it.
Isn't it 4?
There is a 4-way one, yes. No. No, that's a good guess. It's guess and check, okay. It's called guess and check. We're all guessing and checking. There are several methods for this. It's called factor by grouping. Did anybody remember learning factor by grouping last year? Okay, I got any Lord's people in here? Box method? Yeah, and somebody from the West End teaches it also, I can't remember who. All right, well, I'm not going to teach that method. If you use the box method, if you know how to do it, and you get all the answers right, I will give you full credit. But I always have to stop and remember how to do it. It's just not the method that I learned. We're going to learn the guess and check method for trinomials. We're going to learn how to factor things that fall into this pattern. Ax squared plus bx plus c. Now sometimes instead of pluses it'll be minuses. This is our basic factoring pattern. Okay? The easiest ones are the ones where our leading coefficient is 1. Those are usually super easy to do. We'll review that and then we'll do a little bit more. Okay. So it is a trinomial, okay, and the basic factoring pattern is that these trinomials will often factor into two binomials, like this. Yeah, just coming back to some of you. Okay, one of the things you have to do is know what signs you're going to use, and I'm going to tell you how to know what signs you're going to use. You have to listen. This number right here is -6. It's not +6. So whatever two numbers I put in here, those two places have got to give me -6. If I'm going to get a -6 when I multiply, then I need one positive number and I need one negative number. So I'm going to put a plus and a minus. Sometimes it's minus plus, but we can fix that later. Does everybody understand why I have to have a plus and a minus? Okay. Let me erase this whole thing. These two have to give you the first term, right there. Usually that one's pretty easy. There's pretty much there are only two ways to get this that are easy. One of them is to say a squared times 1. We never want that one. Okay, instead we want to just say a times a. Everybody good with that? Different teachers have different techniques of showing this other thing. I'm just going to show you my way. If you have another way of remembering it, that's fine. When I teach this first Algebra 1, I tell them to make a list over here of ways to get 6. So 6 times 1, 1 times 6. Well, actually, I don't do that. 6 times 1 or 2 times 3. Those are my only two choices. Okay? Those are my two possibilities. And that's my guess part. I'm going to pick one and I'm going to guess it. So I put in my A's. Let's say I guess the 6 and the 1. Okay, there's the guess part. And then you need to remember the whole name of this technique. It's not called guess and go work the next problem. It's called guess and check. Now, we have not made a stupid guess. We have made a reasonable guess. For example, this would be a stupid guess. There's no way that can be right because 7 times 3 does not equal 6. It doesn't make any sense to guess that. Okay, so I'm only doing reasonable guesses. I know that the first was right, and I know that the last part is right. All I need to check is the inner and the outer. So 6 times a is 6a, and a times -1 is -1a. And when you add those together, you get 5a. Is this 5a? No. Then this is the wrong answer. Okay? And at this point, at your seat, you would turn your pencil over and erase your guess. Okay? You might want to leave it in there for your notes. That's up to you. But usually you just erase your guess. Cross out that you've done that, if you were keeping up with them, and go back to your 2 and your 3. Next one. Okay? 2 times a is 2a, and a times -3 is -3a, and when you add those together, you get -1a. Is that what we got here? Yes, then that's the right answer. Okay? This is the answer to the question. That's our factoring answer. Y'all remember doing this last year? Yes. We'll just run through a couple of them, and then we'll talk about some of the rules. Okay, I don't have to see a lot of work, although in Algebra 1 I give credit sometimes when people can't find the answer, but they show me some of their steps along the way. But on these really easy ones, sometimes y'all will just get it. It's just because you've done it enough that you just kind of see what the answer is. Okay, 2 binomials. I'll give you just a second on, okay? The first term's easy. What is x squared? That's x and x. That's easy. We'll talk about the sign rules in a few minutes and we'll write it all down in one place. But for right now, if there aren't any minuses anywhere in the problem, there aren't going to be any minuses anywhere in the answer. Okay? There's no minuses in the problem, no minuses in the answer, then both of these are going to be plus. And there's only 2 things that can multiply together, 2 integers that can multiply together to give you 10. 10 times 1 and 5 times 2. Which one do you think it is? I think it's 5 times 2. Sometimes we get lucky and we guess the right one first, and that's 5x plus 2x, and that is 7x. So we got it right first. Okay? Is everybody good?
Was it called Ma too? Because that's what we called it at our school.
I don't know that name, but you can tell me about it later. Okay? I'm sure there are multiple ways to do this. There's a way to do it called factoring by grouping that some people teach. I'm happy with any method. If you remember the other way and you want to show it to me, I'll be glad to look at it. I'm sure it'll be fine. Okay?
So with something like x squared minus 7x plus 10, you can
Okay, I'll do that in just a second, okay? Hang on to that, okay? Okay, so two sets of parentheses, x and x, that's the easy part. I have to have a negative in my answer. There's at least one negative in the problem, there has to be a negative in the answer. If I'm gonna get -4, can y'all all look up here? If I put these two minuses in, just like that, and then I put two numbers in here. Oh, that's not even one. And I do this. Do you see that those two do not give you -4? Does everybody see that? What does it give you? It gives you +4. So it's a bad guess. It should never even be guessed because it's not a good starting point. Okay? What you want to recognize is that if this last number right here is negative, if that last number is negative, then you need one plus and you need one minus. No matter what this is. It doesn't matter what this is. If the last number is negative, then the plus and the minus. Okay? So I've got two choices here. It's 4 and 1, or it is 2 and 2. And I just want to show you, I'm going to guess all of the right answer, and I want you to copy this down. Even if you know what the right answer is, I want this example copied the way that I'm doing it, because I'm showing you something that's going to happen to all of you. Okay? If I make this guess, I get 1x, and I get -4x, and that gives me a middle term of -3x. Yes? Is that the correct middle term?
No.
No. What's wrong with the middle term? Yeah, it's got the right number, but it has the wrong sign. When this happens to you, and it will happen to all of you somewhere, when you make a guess, and the middle number turns out to be the right number, but it has the wrong sign on it, then you want to take your same guess, the x, the 1, the x, and the 4, leave all of the numbers and letters where you had them, and change the signs, okay? Don't change the numbers, change the signs. Sometimes changing the number works, but changing the sign always works. So instead of +1, make it minus, and instead of -4, make it plus. And this will be the right answer. -1x plus 4x gives you 3x. Does everybody see? So when you make a guess and you get the right number but the wrong sign, then write your same guess down and change the signs. Do not change the numbers, change the signs. Changing the numbers sometimes works. Changing the signs always works. Okay? All right, now I've given you, the ones I've given you so far have all started with just a plain old x squared. The problems get slightly more complicated when you put a coefficient in front of it. Slightly. Okay? So two sets of parentheses, and this time x and x isn't going to do it, because x times x is not 2x squared. So I'm going to have to put a 2 with one of them. I usually put it on the front one. It doesn't really make any difference. Does everybody see where you get 2x times x? And now let's talk about signs here for just a minute. And again, when we finish a few of these, we'll try to get all of our sign rules in one place. But let's think about what the signs have to be. So pencils down and look up here. It's my 6. It's pencil down. Okay. If I put 2 pluses here, if I do that, will I be able to get a +5?
Yes.
Will I ever be able to get a -7? No way, not going to happen. Okay, so it can't be 2 pluses. Does that make sense? All right, I'll put a plus and a minus. I can get that way. I can get a negative in the middle if I need it. But when I put 1 plus and 1 minus, am I ever going to get a +5? No, not ever. Okay, so 2 pluses doesn't work, and a plus and a minus doesn't work. My only other option is 2 minuses. When I have a negative times a negative here, can you all see that this negative times this negative will give me a positive, and I will be able to get a negative middle term. Does that make sense? Do I see why the signs are what they are? I put the signs in. Now, when your coefficient, right here, when this is not a 1, then you have twice as many possible guesses, okay? Because it's different, let me just put this in here, it's different to guess 5 and 1, like that. That is a different guess than putting 1 and 5. Can y'all see that those two are not the same thing, okay? When this number is a 1, you don't have to worry about that. But if this is a 2 or a 3 or a 5, then every time that you're making a list of your possibilities, over here on the side, you want to put 5 and 1, and you also want to put 1 and 5, because you don't know which one it's going to be, okay? I don't, in fact, know which one it's going to be. So my first one, negative 5x and negative 2x is, it's that one, negative 7x. And see, this one gives me negative 1x and negative 10x, which is not the same answer. Okay? When the numbers get switched, you don't always get the same middle term. Okay? Okay, let's pause for a minute and let's just write down all of the sign information in one place, okay, to make sure we know what that is. I'm going to write it one way. If you have another way of remembering it, I'm glad to hear it. I'm glad for you to use it. This is our basic formula, ax squared plus bx plus c. If it's all pluses, then my answer is going to be all pluses. If I have ax squared minus bx plus c, that's what we just did. What are my signs going to have to be? For the last term to be positive and the middle term to be negative? Both minuses. And you know what? It's just super easy when you're doing this to say, oh, it's minus plus, and put a minus plus in here. You'll never get the right answer. You have to recognize the sign text. Okay? And then, it doesn't matter what the middle term is. It doesn't matter if it's plus or minus. This makes absolutely no difference. The only thing that matters is that the last number is negative. If the last number is negative, then your sign pattern is 1 plus and 1 minus. Okay? And that's the one where sometimes when you do this, you get the wrong sign on the answer and you go in and then you switch it to minus plus. Okay? Let's see what else I can just do. Okay, so did anybody remember anything from last year when y'all learned this that you think might be helpful to other people? What?
Last year, the video was torture.
It was torture. Okay, I don't know if that's helpful or not.
Don't get frustrated, guys.
Don't get frustrated. Only sunshine. Okay.
Yeah, it makes more sense this year.
Well, that's because you're older and smarter. I don't really know which number I'm on, so I'm just going to pretend like I'm on example 5.
You are.
I am? It's a miracle. All right, now I'm going to give you one that could possibly frustrate you.
So this is just
This is still guess and check. This is a slightly harder guess and check. Okay? And what makes this problem a little bit harder even than the last one is that that first coefficient, not only is it not 1, but it's not prime. Yes? 12 is not a prime number. So here's the thing. I could start this problem this way, because 12x times x gives me 12x squared. Or I could start this problem this way. So 6x times 2x gives me 12x squared. Or I could start this problem this way. So this has got 3 possible starting points. Okay? It's just got more. Now you're not going to have 15 of these, but you might have 1. Okay? Just don't panic. It just takes a little bit longer. Think about your signs. What do the signs have to be? A positive and a negative. I just always put plus minus, and then I change it later if I need to. So here are my starting points. Okay? Now, what are the possible guesses to get 2 at the end? There's only one way to get 2. 2 times 1. But remember, since these aren't the same, not only do I have to try 2 times 1, I also have to consider 1 times 2. Because if I change the order of the numbers, now what I have written on the board right here is what I would call work for this problem. Okay, this is you setting it up, getting it organized. Here are my possibilities. Now, girls, honestly, sometimes y'all just make a guess and you happen to get it right the first time. There's 2 explanations. One, you just are doing it so naturally that you don't realize you're really thinking about it. You know, it's like opening a door. You don't even think about opening a door, you just do it. But have you ever watched a little kid try to open a door? They're not so good at it the first few times they do it. It's all very funny to watch them. So, and sometimes you just flat out got lucky. But here's the thing, if you don't get lucky the first time you guess it, lay it out in an organized fashion. Because it's either one of these 6 possibilities, or it doesn't have an answer. Alright? Now you look at it, there's 1, 2, 3, 4, 5, 6 possibilities. Pick one of them. Try it. Pick one. See if you get lucky. Pick one. There is 1 right answer and 5 wrong answers. Just pick one. And I'm just curious if I've got it on the first guess. Okay. Guess and check is a valid method. As long as we're not just making random guesses, we're making reasonable guesses. Okay, a little helpful hint. You see this big number 12 here? Yes? And you see how this middle number here is not a big number? Okay, I probably wouldn't start with this one. If I had a bigger number here, like a 20 or a 19 or something, I might go with this. But other than that, for that sort of smallish number, I would probably start with one of these other 2. I don't have any idea which one it is. Sometimes you can look at it and do them in your head. Some people are capable of that. Anybody find it? Is it this one? With the 2 and 1? Okay, so sometimes I actually make these problems up correctly. When I go to guess this one, please, you get 8x, you get negative 3x, which is positive 5. So this is one more time for me to drive the point home. It's the right number, but it is the wrong sign. So don't go up here and switch the numbers. Go up there and switch the signs, and that will work for you. So your correct answer is going to be 3x minus 2 and 4x plus 1. Okay? Good? So how many of you know one doesn't have something that has multiple possibilities? I don't want the right answer. What I want you to write down for me is a list of reasonable guesses. I want you to write down for me your organized list. What are the possibilities that I might need to consider? And I'm going to teach you another shortcut. So don't start guessing them yet, because I'm going to show you how to get rid of some of them. Okay. Now, how many possible guesses do you think there are? How many reasonable possible guesses do you have? How many of you have 2? At least 2. There we go. How many have at least 3? How many have at least 4? How many have at least 5? 6, 7, 8, 9. 9? I only have 8. Oh, that's okay. All right. So you all start off with the possibility of 6x and 1x, and the possibility of 3x and 2x. So that's 2 ways to start it. Yes. Now, what are the only things that are reasonable to guess in the back end of this? Oh, wait, I forgot the signs. Plus and minus. Yes. Okay. So what are the only reasonable things to guess for 10? 10 and 1 and 1 and 10. Don't forget to check to consider switching them. 5 and 2 and 2 and 5. And you have that same list over here. 10 and 1, 1 and 10, 5 and 2, 2 and 5. Okay? And now I'm going to show you a way to eliminate some of these that cannot possibly be right. Okay? But I need to make sure everybody knows where I got all these guesses from. Yes? I hate to have to guess 8 different things. I looked at a video last when I came to it. All right. Look at this problem at the very beginning. The 6, the 11, and the 10. Do you notice that they do not have a greatest common factor? There's no GCF besides 1 for 6, 11, and 10. Does everybody see that? Okay. If there's no GCF at the beginning, then none of our guesses should generate a GCF. Let me show you what I mean by that. If I were to put a 10 right there, do you see that the 6 and the 10 have a GCF? Yes? That's not going to be the right answer. There was no GCF at the beginning. There will be no GCF here. I don't have to guess that. It's not going to be right. Okay? Can't possibly be. Okay, do you see another one of these that I don't have to guess, because if I put it in, it's going to give me a GCF?
2 and 5.
The 2 and the 5. You see if I put the 2 and the 5? This is going to give me another GCF. There's no way it can't possibly be that answer. I don't have to guess it. Okay, look at the other list. See if you can eliminate any of the possible guesses from the other list using that same idea. Can you? Can you?
5 and 2.
The 5 and the 2. If I put 5 and 2 like this, then I end up with a GCF over here. Okay, so that can't possibly be it. I don't even have to guess it. Is there another one? 1 and 10. So now instead of having 8 possible things to guess, I've only got 4. So even if it is the last one, it won't take me long, right? Okay, find it. At this point, the people who get it on the first guess are not smarter than you are. They're just doing all the work in their head. That's what they're doing. Most of the time. Sometimes they're just lucky. Does it sort of make sense that, like, sticking a 10 here, and if you get 10 times 6 is 60, that's a really big number. It's probably not that one. Does that sort of make sense? We'll be doing that until later. I think it's one of these. Oh, for mod 6 people. I think it's one of these. I can't see you reading my hand around.
That's the same.
Is it the 2 and the 5? Yes, like this. And I didn't have to change the signs, it came out right. Okay? Alright, so we're going to practice that one more time. We're not going to actually worry about finding the right answer, but we are going to practice making an organized list of guesses first, seeing if we've got all the possible guesses, and then eliminating the ones that cannot be right, so that we don't have as much work to do. Okay? Last example. I've lost count. 7? Is this the 7th one? Yes. All right. the basketball game? Okay, write your possible, first guesses down.
Have your attention, please. The junior varsity and varsity basketball teams may now be dismissed, and good luck.
Well, only the homework from person to be in, no. I'm just kidding. It's, all supposed to be done. Okay, so who's leaving, raise your hand again, so it's me. Great. The rest of you keep on working. Don't start guessing or yet, you're just making lists. I like to shuffle. And, sorry. What do you have, please? The first worksheet says factor this one down. This one tells you which method to use, okay? You're going to practice individual methods here, right? The second worksheet and decide which method you don't actually factor, which you have to see. Okay, now I have to figure out which one I'm supposed to do, okay? All right. So how many possible guesses? There were a lot. So 24 is 1 and 24. 2 and 12. 8 and 3, is that right? 3 and 8. 6 and 4, 4 and 6. Yes, and then that whole list over here. Over again. Yes? When I'm doing one that's long and hard, I tend to be very organized about it. I start with the biggest one and work my way down. Okay, so how many more here? 24? No, 12. 1, 3, 4, 5, 6, 16 guesses. 16 guesses. Which ones can we cross out? Some that will result in a GCF. Okay? Any that will result in a GCF. This one? Gone. This one? No. This one? This one? Gone. This one? Gone. This one? This one? And this one? Look at that! Next closed door. What about on the second side over here? What about the ones with the 2 before I start actually doing my little guesses check? I can cross out this one because of that 2. I can cross out this one because of that 2. Y'all see? I can cross out this one because of that 2. Well, both of them. It can't be any of them. So instead of 16 possible guesses, how many are there really? You said 2. I bet you can all get the right one on the first guess. And if you don't, I bet you'll get it right on the second guess. Okay? That's because I have great confidence in you. Yeah, I really am not looking forward to the 24 over here because I'm going to get 24 times 4, and that's a pretty big number, you know? I would start with 3 and 8, which I think is right. Oh, I forgot to put my signs in. That's very bad. What are the signs? Minus and minus. They both have to be minus. And I'm pretty sure this one works, doesn't it? Yes? Okay. All right, so you like that little trick about how you cross out some of those guesses on those long, nasty problems? Yes? Excellent. Okay. Almost finished before the... Your homework is 2 worksheets. And the first one, I give you the method and tell you what method you're supposed to use. And that will not happen when it's time to take the quiz. This is just for practice. Okay? So, did we all get the princess factoring? 1 through 6 is GCF. 7 through 12 is the difference of two squares. 13 through 26 is guess and check. And 27 through 30 is sum or difference of two cubes. Now, if you get, on the easy ones, on those guess and check, you probably won't need a separate sheet of paper, but a couple of them you may need to attach a piece of paper to do this kind of thing, just for a few of them, okay? All right, the second one. Might actually be one that you decide you want to start with. Maybe not. This is for you to look at and decide which kind of factoring would I do. You're not going to actually do it, okay? You have to decide for yourself which kind of factoring. Because when we get ready to have a quiz, it's just going to say factoring. And you're not going to have me telling you which kind you're supposed to do. You have to take. So there's 24 columns all mixed up, and they are each only one kind of factoring. Okay, the next time I see y'all, we're going to talk about problems that have to be factored twice. But in these cases, they can only be factored one time, so you're just picking. So everybody, for example, take a look at number 1. Look at it. Okay, is it a sum or difference of two anything? No, because it's got 3 terms. So what kind of factor? Okay, so down at the bottom, where it says guess and check, put the number 1. Y'all see what we're doing? Y'all see how this works? Okay, and don't work it. You're just identifying. If I were going to factor it, this is the kind of factoring I would do. Does that make sense to everybody? Perfect. Okay, and on 6, if you are watching this video, your 2 worksheets will be on downloads page. All right. Bye, Line 6. Y'all say bye, Line 6?
Bye.
Posted to